6.3 trigonometric functions of angles. So we have POQ as a right triangle with acute angle theta coming out from the origin. So point P has the coordinates xy and it's on the terminal side of theta. The opposite side from theta is going to have length y from the point, because that's how far up it went. It will have the adjacent side be a length x, because that's how far it came out. So we're going to use the Pythagorean theorem to solve for the hypotenuse, which we label r. So you go x squared plus y squared equals r squared. Take the square root of both sides, you get r to be the square root of x squared plus y squared. So we're going to let theta be an angle in standard position and let p xy be a point on the terminal side. So if r equals the square root of x squared plus y squared is the distance from the origin to the point x comma y, then we can find the sine, the cosine, and the tangent. Basically, we're saying here's theta. Sine is opposite over hypotenuse, so y over r. Cosine is adjacent over hypotenuse. Adjacent is x over r. The tangent of theta, opposite over adjacent, y over x. The cosecant is going to be the reciprocal of the sine, so r over y, and we have to say that y cannot equal 0. Secant will be r over x, where x cannot equal 0. And the cotangent will be x over y, and y cannot equal 0. We're saying that these can't be 0 because you can't divide by 0. If we tried, some of the trig functions will be undefined. So for example, tangent of 90 degrees. (90 degrees) on the unit circle is the point 0, 1. You would want the y over the x, so it goes to 1 over 0. So you can't do it, it's undefined. So as you see from this example, you get it to be undefined when the bottom's 0, so either x or y is going to be 0. This is when you may have a trigonometric function be undefined. This is called quadrantal angles. It's angles that are coterminal with the coordinate axes. So that means that one of the sides is on an axis. So as a review from last chapter, the signs of trigonometric functions, all students take calculus. All are positive in the first quadrant. The sine and the cosecant are positive in the second quadrant. Tangent and cotangent are positive in the third quadrant, and cosine and secant are positive in the fourth quadrant. So when we find trig functions of angles, it's like finding the reference number, but in degrees, and it's called the reference angle, which we will define after our first two examples. So we are looking for the cosine of 135 degrees. We use the knowledge that we have on the unit circle, and we know that we start over here, this is 90 degrees, down to here would be 180, so we stop in between. Here's 135 degrees. We went 90, so after that we went 45 additional degrees. 45 is going to be our reference angle. It's like the reference number, except now we're in degrees. So we stop here. This is our 45 degrees. And from our knowledge of the unit circle, we know it's the point root 2 over 2, root 2 over 2. Cosine's your x value. We ended in quadrant 2. From all students college ready. I'm sorry, not all students college ready, that's our school motto. All students take calculus. Only signs positive in quadrant 2. So we want the cosine of 135 degrees to be a negative root 2 over 2. Looking for the tangent of 390 degrees. 390 is over one full circle. So subtract 360 from it, and you get the tangent of 30 degrees. 30 degrees is stopping right here in the unit circle. It's the first important terminal point on the unit circle. If you use the left-hand trick, you find it's root 3 over 2, 1/2. We're in quadrant 1, even with the 390, because it would have been a one circle, and then an extra 30. So we get the tangent of 30. It's really the sine of 30 over the cosine of 30. Sine is your y value, so 1/2 over root 3 over 2. So you're really taking 1/2 times 2 over root 3. You get 1 over root 3, but you have to rationalize the denominator, and you get root 3 over 3. So the tangent of 390 degrees is root 3 over 3, and we're in quadrant 1, so it's positive. So the reference angle. We're letting theta be an angle in standard position. The reference angle theta, and we put a line over it, associated with theta is the acute angle formed by the terminal side of theta and the x-axis. So let's jump right into an example. Theta can be given in either radians or degrees. So our first one's given to us in 5 pi over 3. It has pi, so it's radians. So we need to mark it on the unit circle. Where will it fall? 5 pi over 3. That's bigger than 1 pi, but not quite 2. So we have to go, here's pi over 2, here's a full pi, 3/2 pi, and we stop here. This is the 5 pi over 3. How much more do we have to complete to get the full circle, or to hit the x-axis? Pi over 3. So that means pi over 3 is our reference number. And that's all we wanted. So, what if theta is given to us in degrees? We have theta being 870 degrees. So, we need to get this down in between 0 and 360. So, 360 is subtracted. Take away another 360. And you get 150 degrees. We learned the degrees of the unit circle, and it's coming into practice right now. Starting is degree 0, here's 90, here's 180, 270, and then end at 360. 150 falls in between 90 and 180. So we stop over in here. Here's our 150 degree angle. And to complete it to the nearest x-axis, we have to go an additional 30 degrees. So your reference angle is 30 degrees.